In the previous video, I discussed some basic ideas with fractions. In this video, I want to discuss operations with fractions: adding, subtracting, multiplying, and dividing. As before, I would like you to have practice doing the operations both with and without a calculator, although you can certainly use a calculator for any of the assessments. My purpose for doing operations without a calculator is simply so you can refresh your knowledge on how and why those operations work. Let me start off by reviewing adding fractions with different denominators. You can see here I have the problem 2/3 plus 1/2, and I have a picture showing something divide up into thirds and then the same size rectangle be dividing up into halves. Well, I certainly cannot just go through and add together the thirds and the halves because I have different size pieces. What I have here is I have 2/3 plus 1/2. But since the pieces are different sizes, I just cannot add those pieces together. It'd be like adding apples and oranges. So what I need to do is I need to find a common denominator. I need to change those pictures, if you will, so that they have the same size pieces. So an easy way to go about doing that is to multiply both of these using the multiplication rule of 1. I'm going to choose to multiply the very first fraction by 2/2, which once again I can do because this is equal to 1, and I get 4/6. If I want to show that on my picture, I'm going to multiply by 2/2, which means I'm going to change that into sixths. So I divided that in half again because of that 2/2. So now I have 4/6. On the bottom, I'm going to go through and I'm going to multiply this by 3/3. And once again now I use the multiplication rule of 1, I get 3/6. And since I multiplied by 3/3, I want to put this into 3 more parts, and you can see that now I have 3/6. So I have 4/6 plus 3/6. And you can see now that they are the same size pieces that I have. So I have a total of 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7/6. So when I add these together, I get 7/6 for my answer. Now, I would not be able to leave it this particular way because this is an improper fraction. So this is equal to 1 and 1/6 altogether. If I added all these up, I would actually need 2 of these rectangles divide up into sixths. One of them would be completely filled in, 6/6 plus another 1/6. Subtraction with fractions with unlike denominators works the same way as addition, so I want to talk about this particular problem in 2 different ways. I have 7/8 subtract 5/6, and the very first thing I need to do is I need to make sure that I have a common denominator, so I need to change the 8ths and the 6ths. What many people do is they take a look at those 2 denominators and they just multiply them together to get their common denominator. 8 times 6 is 48. And then figure out what do they have to multiply 8 by to get 48. The answer would be 6, so you would get 42/48 if you use the multiplication rule of 1. Here you'd have to multiply 6 times 8, so I have to multiply the 5 times 8, and I get 40/48. And now I'm going to go through and subtract. 42/48 minus 40/48 gives me an answer of 2/48. That's not in lowest terms because I can divide both of these by 2/2, so I get an answer of 1/24. Now, as I'm going through and doing that problem, you can certainly go through and do it that way. But let me talk about doing the problem just slightly different. And once again, it doesn't matter, and you'll probably be using a calculator anyway, but I just want to make sure. That 8 and that 6, over here I chose 48 as the common denominator, but there is a smaller number I could have chosen because a common multiple of 8 and 6 is 24. So I could have chosen 24, multiplying the top by 3/3, I get 21/24. Multiplying the bottom by 4/4, I get 20/24. And then subtracting, I get that answer of 1/24. Notice you get the same answer both ways. It's just the second time I did not have to reduce down to lowest terms because I used the smallest common multiple of those two denominators, the 6 and the 8. When adding and subtracting mixed numbers where the fractions have different denominators, the process works very similar to what we just got done doing, but I do want to go through quickly just how to do these just as a review. The very first one, I have 5/7 plus 1/3 for the fractions. So I need to go through and find a common denominator, and my common denominator could be 21. So I'm going to multiply the very top fraction by 3 over 3, and I'll get 15 over 21. I'm going to multiply the bottom one by 7 over 7, and I get 7 over 21. Now I just go through and add 15 21sts plus 7 21sts is equal to 22 21sts, and my 5 plus my 2 gives me 7. Of course, I cannot leave it as 22 over 21 because that is an improper fraction. So if I change that to a mixed number, I am going to get 1 and 1 21st. So I'm going to be adding together the 7 and the 1. I'm going to be getting 8 and 1 21st for my final answer. For the other problem, I am subtracting, and I have thirds and fourths. So I'm going to use a common denominator this time of 12. If I multiply the top one by 4 over 4, I get 8 twelfths. If I multiply the bottom one by 3 over 3, I get 9 twelfths. And now this presents somewhat of a problem. I want to take 8 twelfths, subtract 9 twelfths, but I can't take 9 from 8. So I'm going to have to go through and do some regrouping. I'm going to take 1 away from the 4, and so now I'm going to be left with 3. That 1 that I took away, I am going to think of it as the fraction 12 twelfths, because 12 twelfths is equal to 1. So really what I have on the top right now is I have 20 twelfths. Well, 20 twelfths subtract 9 twelfths does give me 11 twelfths, and now 3 subtract 2 gives me 1. So my final answer is 1 and 11 twelfths. Before moving on to multiplication and division with fractions, let me just have you go through and do these two different problems. And I'd like you to do these problems, if possible, first just with paper pencil, then check them with a calculator just to make sure you know how your calculator does work. So if you could pause this video and then turn this back on again when you're done, that would be great. Okay, hopefully you've had a chance to go through and do these problems. Let me run through and do these problems also fairly quickly. The very first problem, I have denominators of 3 and 5. So I'm going to change both of these to 15ths. If I change the top one to 15ths, I need to multiply by 5 over 5, and I get 10 15ths. To change the bottom one to 15ths, I need to multiply by 3 over 3, so I get 9 15ths. The 10 15ths plus the 9 15ths gives me an answer of 19 15ths, and then I add together my whole numbers, 4 plus 5, I get 9. But once again, this is an improper fraction. I can't leave it as 19 15ths. That's equal to 1 and 4 15ths. So now I'm going to add together the 9 plus the 1, and I get 10 and 4 15ths for my final answer. For the subtraction problem, my common denominator would be 24. So I'm going to multiply this top one by 3 over 3, and I get 3 24ths. I'm going to multiply the bottom one by 8 over 8, and I get 16 24ths. I can't subtract 16 24ths from the 3 24ths, so I'm going to have to regroup, take 1 away from the whole number 7, make that a 6, and that 1 that I took away, I'm going to think of it as 24 24ths. So now on the top I really have 27 24ths. And now I'm going to go through and subtract the 27 24ths minus the 16 24ths, which gives me 11 24ths, and then the 6 minus the 5 gives me 1. So I get a final answer of 1 and 11 24ths. The 11 24ths is already in lowest terms, so I don't need to worry about doing anything else with the fraction. I know that I have gone through all of this very quickly, and once again the reason for this is just to give you a very brief overview again of adding and subtracting with fractions. There are many websites out there that you'll be able to find, and I will have some also on this particular website that you can go to if you would like additional practice. As I've said, what's most important is that you can do these problems also with a calculator, as you will be using a calculator for the vast majority of the rest of this course. Many people say that multiplication and division with fractions is much easier than adding and subtracting. And I'm going to just go through and show you a quick picture of something 4/5 times 1/2. If I want to do 4/5 times 1/2, that really means that I have 4/5, but I only want half of it. So I could go through and I could take my 4/5, which I have in the picture, and I only want half of it. So I divide it in half. Now, how much do I have? Well, now I have 4. If I divide this in half, I'm only talking about 4 out of a total of 10 pieces. So this is equal to 4/10. So multiplying by fractions, you can just go straight across and multiply. Another way to take a look at this in picture form is to take a look at the bottom picture again that I have. Once again, I am showing 4/5. Well, I only want half of it. So if I only want half of it, I only want this amount of it right here. I only want half of those 4/5. Well, that is equal to 2/5 for an answer. But notice that if I come back up here to this original problem, 4/10, 4/10 is not in lowest terms. If I would divide that by 2/2, I do get 2/5, which is exactly the same thing. So showing it in picture wise, you can do it several different ways. The big thing though is when you are multiplying fractions, you are really just multiplying the denominator straight across and also multiplying the numerators straight across. As a reminder, if you're given a problem where you are multiplying mixed numbers, you'll need first of all to go through and change each one of these mixed numbers into improper fractions. So 1 3/4 is equal to 7/4. 2 1/3 is equal to 7/3. And now I'm just going to once again go straight across and multiply. 7 times 7 is 49. 4 times 3 is 12. I do get an improper fraction, which I'm going to change to a mixed number. 12 goes into 49 4 times. I would have 1 left over. So the final answer to this would be 4 1/8. So how about dividing with fractions? You probably remember a rule about inverting the second fraction and then multiplying. So let me just talk about why that works. Let's say you were just given the simple problem 8 divided by 2. Everyone knows 8 divided by 2 is equal to 4. But if you divide something by 2, it's exactly the same thing as multiplying it by 1/2. Dividing by 2, multiplying by 1/2 are exactly the same thing. So we use that whenever we go through and we divide with fractions. If I was given something like 2/3 divided by 1/4, rather than doing a division problem with fractions, I'm going to change this. And I'm going to keep the very first number the same, just like I kept the first number the same here. Rather than dividing, I'm going to multiply, and I am going to invert this second fraction. Instead of 1/4, I'm going to make it 4/1. It's exactly the same thing, for the reason that times 1/2 is the same thing as dividing by 2. So now that I've changed this to a multiplication problem, now I can just go through 2 times 4 is 8, 1 times 3 is 3. And if I change that from an improper fraction to a mixed number, I get 2 2/3 for an answer. Dividing by mixed numbers uses the same process as multiplying. First of all, go through and change both the mixed numbers into improper fractions. So 2 3/5 would be the same thing as 13/5. 1 3/4 would be the same thing as 7/4. So I have 13/5 divided by 7/4. Now I'm going to go through and I'm going to change this to a multiplication problem. I'm going to keep the very first fraction the same, but I'm going to invert that second fraction and I get 4/7. Now I can multiply straight across. 13 times 4 is equal to 52. 5 times 7 is equal to 35. And I would go through, since that's an improper fraction, and change that into a mixed number, and I would get 1 and 17/35 for the final answer. So once again, I have two different problems here. I'd like you to practice these. If you could, please do these first without a calculator, and then grab your calculator. Make sure that you know how to do these problems on your calculator as well. So you can turn this off and turn it back on again when you are ready. Okay, in order to go through and do the first problem, I'm going to take both of the mixed numbers and change them into improper fractions. So for the first one, I get 5/3. For the second one, I get 9/4. And then I'm going to go through and just multiply. 5 times 9 is equal to 45. 3 times 4 is equal to 12. But because this is a improper fraction, I need to change that. So 12 goes into 45 3 times. I would have 9 left over, so I get 3 and 9/12. Now I cannot leave it as 9/12 because that is not in lowest terms. So I could take that 9/12 and divide the 9/12 by 3 over 3, and I would get 3/4. So the final answer to the problem would be 3 and 3/4. For the other problem, I'm going to start off doing exactly the same thing. First thing I'm going to do is I am going to change both of these into improper fractions. So I get 16/5, not 16/3, 16/5 divided by 5/3. And then I'm going to use the idea of changing this to a multiplication problem. The very first fraction stays the same as 16/5, but I'm going to invert the second fraction and get 3/5. Now I am going to go through and multiply straight across. And I get 48/25. And I'm going to change 48/25 back into a mixed number and get a final answer of 1 and 23/25 for my final answer. As I said, if you would like additional information or practice on doing this with paper pencil rather than calculator, there are all sorts of websites available that will go through this process with you. I wanted to do it quickly just to give you an idea of how it works, but what is most important is that you can do them with your calculator. I'd like to finish off this video by combining the ideas of algebra and operations with fractions. So you can see on the left hand side I have different variables and their values, and then two different problems. I'd like you to stop this video, do those problems, and then turn this back on again and check your answers. Okay, for the very first problem I am just going to go through and replace what these letters stand for. So A is equal to 1/2, so I have 1/2 plus 2/3 divided by 3. Remember that you do have to follow my dear Aunt Sally rules. So the very first thing I need to do is I need to do 2/3 divided by 3. So 2/3 divided by 3 means 2/3 multiplied by 1/3, and I still have 1/2 plus that. And I'm still going to do the multiplication first. So I get 2 times 1 is 2, 3 times 3 is 9, so right now I have 1/2 plus 2/9. I'm going to continue the problem over here. So if I have 1/2 plus 2/9, now I need to find common denominators, and that's going to be 18. I'm going to go through multiply by 9 over 9 and get 9/18 for the very first fraction, and multiply this by 2 over 2, and I'll get 4/18, and adding those together, my final answer should be 13/18. For the second problem, once again, I'm going to replace what I have. So I have B is equal to 2/3. I have 2/3 subtract 1/2, and that's the top part of that fraction. And 2C, C is equal to 2, so I have 4 minus 4 on the bottom half. If I go through and if I solve both of these, right away I see that my denominator is equal to 0. So it really doesn't even matter what's in my numerator. I could go through and do 2/3 minus 1/2. I would get 1/6 for that answer if I went through and did that, but it doesn't matter at all. Since 0 is the value of the denominator, we say that this is undefined. Before going on to the next video in this module, which is really the meat and potatoes of the module, I would like you to do 5 quick problems to check your understanding of this video. Once again, please do them both with and without a calculator, although it will be most important that you know how your calculator works when doing the problems. If you do well in the quick check, you are ready for the next video. Remember, if you want more practice or additional explanations of how to do operations with fractions without a calculator, you can look at the additional websites I've listed. I am always available to answer any questions you may have as well. Thank you.